Hi everyone, it's Joe again, and this is going to be our third and final video on the position time graph. Notice I have a new graph with new information here. I want to talk about quantitative analysis as compared to qualitative. If I say it's a beautiful sunny day out there, that's qualitative. If I say it's 25 degrees out there, that's quantitative. Quantitative means quantity, a number. So I want to combine the two, and I want to tell a story of what's happening to this object that's moving. And here we have our graph. And before you start telling the story, what I want you to do is figure out or calculate the velocities in each interval. I want you to notice that the slopes are changing. There's positive slopes, less positive slopes, zero, steep negative, and positive again. Notice that this object, its final displacement is zero. Why? It started at the origin, it did a little trip, went around, came back through the origin into the negative area, and returned to the origin. Again, its displacement is zero. The distance, that's a different story. What was the distance that this object traveled? Well, it went to the positive 15. It went all the way back through the origin into the negative 5 position, and then it returned to the origin again. So it went up 15, down 20, but it still went 20. So there's 15, 20, that's 35. Plus it went back to the origin again. So it traveled 40 meters altogether. And it traveled 40 meters in how much time? 9 seconds. So you can figure out what that would be as far as its speed is concerned. We know the velocity is 0 meters per second, and really there's no direction with 0. So I want to solve all the different intervals, all the velocities, and I want to talk about it at the end. So let's just use B as an example. Interval B. Whoops, sorry. And I'm not going to spend a long time on this, but I'm just going to tell you that the slope of B is easy to tell. We know that the run is 2 seconds. So let me put that over here. The slope of B, we know the run is 2 seconds, and the rise is 5. And 5 meters, which is equal to 2.5 meters per second. So I want to do that with every interval. I want to solve every interval. What would I do? I'm really not going to be able to write it out because I don't have the room here. But I want to put it this way. The object started from the origin. It went at a constant speed for 2 seconds. And during that 2 seconds, it covered 10 meters. During that time of constant speed, it traveled at 5 meters per second in the positive direction. So all that stuff. And you do all your calculations first, and then you include them with your storyline. At the 2 second mark, the object slowed down to a speed of 2.5 meters per second in the positive direction and stayed that way for 2 seconds. At the 4-second mark, it remained stopped or at rest for 1 second, at which time at the 5-second mark, it reversed its direction, went 20 meters in the negative direction, ending up at the point -5 on the other side of the origin, and so on. Okay, so this is what I want you to do. Calculate first, then tell the storyline and include as much information as you can. This particular question would probably be worth 10 marks on a test. So if a test is worth 70, it's a substantial part. If you want to get the full marks for it, then don't try to cut corners. Just get all the information here. Please do not write it out in point form. Write it out like you would a paragraph. Okay, you can include as I said, you should include the final displacement, the final average speed, all that kind of thing. Displacement, distance covered, we talked about that already. I could also ask you questions like, what interval was the object moving the fastest? Well, the object was obviously moving the fastest in D, because that's where the magnitude of slope is the greatest. What interval was the particle moving forward? Well, in the interval 0 to 2 seconds, the interval 2 seconds to 4 seconds, and the interval, I think that's 7 to 9 seconds. So there's all kinds of questions I could ask on this, but it's that storyline thing that I want you to do. We did that last night. For those of you who missed the class, we did that as an exit slip, and everybody did pretty well on it. And in fact, I gave you all full marks for it. Even though some of them weren't perfect, you got the idea. Okay, so it's kind of like an attitude thing. Just give me what I want and you'll get the marks. So I'm going to leave that position time graph for now. I will see you next class, and our next graph will be the velocity time graph. And so in the meantime, have a great day, and I will talk to you soon. Bye.